All right, in this video, we're going to look at application problems with exponential growth and decay functions here. Now, I totally forgot to give you the answer to the what's it puzzle in the last video, so if you said put 2 and 2 together, you are correct. So here is the scenario, and this is actually a classic episode of Star Trek. The crew of the USS Enterprise finds 15 tribbles aboard. So these kind of mutant alien creatures, they are called tribbles. And if they double every hour, how many tribbles are on board after 8 hours? So the typical growth equation we use is y is equal to a times b with an exponent of a variable, so to the x power, where a is the initial population. So what is the initial population of our tribbles? Let's see, 15 on that one. B is the growth rate, the rate at which these things multiply. All right, so all we really have to do is fill some things in and then figure out how many are aboard the Enterprise after 8 hours. So y is equal to, our initial population was 15. Our growth rate was, so it says double every hour. So if we want something to double, we have to multiply it by 2. So we'll say 2 to the x power. And then from there, we just have to fill in, let's see, our x is equal to 8. So we'll say 2 to the 8th power. And then we get out our calculator and solve this. So let's see, 2 to the 8th power is 256 times 15. And so there would be 3,840 tribbles on board after 8 hours. So 3,840. And that's quite a remarkable growth since we only started with 15. Okay, so now the crew is overwhelmed with the population of the tribbles, and they really need to start getting rid of these things. So our new scenario is going to be, so this was a growth equation. So we actually want to come up with a decay equation so we can actually get rid of this and figure out when these things will essentially be gone. So the scenario on this one is the crew of the Enterprise is removing these things at a rate of 10% every hour. So how many have they gotten rid of after 8 hours? So we're actually going to use the same general equation. So remember, so what is A in this? A is always the initial population. So on this one, we're actually going to we're going to use our previous number of 3,840. So this is actually going to be our initial population for this one. And what do you think B should be? So this is the rate at which they remove them. So this is kind of confusing. If you said 0.1, you would actually be incorrect. Sorry. So let's think about this. If I put a 1 right here, this would be 100%, right? So if they were removing them 10% every hour, it would actually be 90%, or 90%, or 0.9. So this is actually what we have to plug in right here. So we're actually going to use 0.9 for this one. So of that 100% population, every hour there's 90% of the previous population. So hopefully that makes sense. It's, I think, sometimes kind of difficult to think about that way. Okay, so this just is a calculator problem. Sorry, we need to plug in 8 right here. So we need to substitute 8. So 3,840 times 0.9 to the 8th power. And let's see how many tribbles are left after 8 hours of 10% removal. So let's do 0.9 caret and then 8. So we get this number, and then we have to multiply that by 3,840. And we discover that there are, let's see, 1,653 tribbles left on board. 1,653 are remaining after 8 hours. So it looks like they still have a lot of work to do, and maybe they should up their efforts to 20% per hour. And this is also operating under the assumption that the tribbles have stopped multiplying, and this is their current population. So, all right. For your homework, I want you guys to try these right here. Just a couple problems, and if you have any difficulty with these, just send me an email.